The sun is said to be 93 million miles away from the Earth. So 93 million miles, my decimal point, it would be there because this is a whole number. If scientists were talking about this, they would not want to see all of these zeros, and they would not want to see expanded notation where they would have to look at each of the columns. So they're going to move the decimal point between the 9 and the 3 because 9 is one of these numbers. It's a number larger than 1 but less than 10. So this decimal point scoots over here and gets placed. 9.3. Everything else is zeros, so I can stop. I know I'm going to multiply it times 10 because we're in base 10. And now I have to count how many places over this decimal point moved. 1, 2, 3, 4, 5, 6, 7. So the shortcut for this is 9.3 times 10 to the 7th. In our next example, we'll do scientific notation on the fractional side of this number line. Once again, we have a confusing amount of zeros here before we get to the numbers. We're going to be looking at a number that is 1 or between 1 and 9. And that would be right here with the 6, after the 6. So the decimal point gets moved here. And the scientific notation would be copying this number, 6.32, times 10, because we're in base 10. How many columns did we move this? It started here at the railroad track and went 1, 2, 3, 4, 5. But we're in the fractional numbers, so this would be a negative 5. So that would be the scientific notation for this number on the felt board. What if our next example was let's give this a lot of zeros. All right, that's quite a few zeros before we hit our numbers, and scientists are so afraid that they're going to misrepresent one of these zeros, or just have a careless error. So the decimal point is moved to the first number that is 1 or between 1 and 9. Here we have it right here. So I'm going to move this decimal point this way. Remember, we are in the negative exponents, so because this decimal point is going to the right, so we're going to copy this number, 9.384 times 10, and how many columns did we go before we hit the decimal point again? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is a negative 9. That would be a negative 9 exponent. Well, we've got to move our decimal point way over here to the 2, after the 2, because that is our first number that is between the 1 and the 9. And we're going to go 2 times 10. We know it's negative because we're going to the right. This decimal point is moving to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and I'm counting this one too, 15, because we have to hit the decimal point in order to make our number. So this would be 2 times 10 to the negative 15. These numbers really do occur in science. Scientists may have to talk about the number of miles from one planet to another, or the number of water molecules in the ocean, or perhaps the population of the world. On the small side of it, maybe the diameter of a red blood uh, cell. So these numbers occur with science, and the scientific notation is a way for scientists to talk with each other without confusing themselves with too many zeros.